Hey everybody, thanks for tuning in to watching this video. We're going to continue our course on the Intro to Networking. So welcome to Intro to Networking. I released another video which talked a little bit about the TCP/IP protocols and the umbrella structure and a little bit about that. So now we're going to go into just the next step. Now I'm starting off with some of the real basic things for you guys. So if you're more of an advanced IT guy, you may not get as much out of this film. This is for the newbies. This is for the people that are completely green, that don't know anything about networking. Because I want to talk in this video about what is an IP address, what is a public IP address, what is a private IP address, and what is NAT and what is DNS. So we're going to talk about that. I think that these are things that are very important to know before you actually begin your journey into some of the CCNA, the Cisco, or any kind of the CERT programs. You have to understand these concepts. You have to understand the basics before you can actually progress and know what you're doing when you start working with actual devices in the real world or in your labs, in your classrooms. So this is welcome to the Intro to Networking. We're going to talk a little bit about some of these concepts. So what is an IP address? Well, any device that connects to another device via network has an IP address. So everything gets one of these. PCs, printers, fax, scanners, phones, cell phones, voice over IP systems. Now even Coke machines, vending machines, machines like that, they actually have IP addresses because anything that's going to connect to any type of a network, they have an IP address. All of our fun toys, they have addresses too. So the servers, the routers, the switches, all that fun equipment that we get to work on in the networking world, all of those are going to have their own IP addresses, and then for the most part, we're going to be configuring other IP addresses for our networks. We'll get into all that kind of stuff later. Well, what is an IP address? Well, an IP address is a unique identifier. It's given to every single device that's connected to a network. It's similar to like a car license plate. So everybody that drives a car out there, they have a license plate on that car. That license plate is completely unique to that car. That's kind of like what an IP address is. So when you have a device, it is assigned an IP address. That's what allows it to actually connect to a network and communicate with other devices out there, whether it's a computer wanting to get onto the internet, or whether it's a cell phone trying to make a call, or a fax machine trying to send a fax. You first have to have an IP address to that device in order for it to actually be active in connecting to the network. Another really good example is kind of like an email address. You can't send someone an email address if you don't have an email address, if you don't have an email account. So you have to have an email address first before you can really do anything. And that's the same as all these devices. So everything out there in the world that connects to a network, they have to have an IP address. That IP address is given them statically or dynamically, which means they're either manually put in or they are automatically assigned to that device. Most of the things we do use a dynamic structure, which means that it is automatically assigned to us. That's why we may not be at this point as aware of it. If you connect to a network right now, your IP address is given to you from the DHCP server. We'll talk a little bit later about that as we proceed here. There are a couple formats of IP addresses. There's really two. Two are the most common. You have IPV4 and IPV6. Your IP addresses and IPv4, they're really comprised of 4 numbers that are segmented by dots. For example, 172.12.15.153. That is an IP address. IPv4 uses a 32-bit address structure, which does limit the address space. Because we're only talking about 32 bits, we are running out of address space out there. That's why IPv6 has come along. IPv6, it uses a hexadecimal. It's a 128-bit structure. It's far more complex, but it has far more address spacing. Because rather than just the 4 segments of numbers separated by dots, it's actually going to be a segment and a grouping of 8 characters separated by dots. And it uses hexadecimal, which means it's going to have numbers and letters combined that are going to equal a particular value. We'll definitely talk about that later as we get into it. I'm going to jump into a real quick whiteboard slide for you guys so we can have this IPv4 explained just a little bit better. Perhaps you'll understand the concept. So here we go. So there are two forms of IPv, and it's IPv4 and IPv6. IPv4 is a 32-bit architecture system. That's really the most prevalent system that we have out there today. We'll get into IPv6 a little bit later. It's a little bit more complex than this. So IPv4, it uses a 32-bit system. Like we talked about before, it's going to be 4 numbers that are separated by a dot. So it would be something similar to 172.16.254.1. We'll break that up. I'll make that a little bit bigger down here. This is just a quick example. So it's a 32-bit, basically 4 groups of numbers separated by a dot. Now these groups of numbers, they're really referred to as octets. Spell it right for you guys. So you have octets. There's 4 octets. Each octet is basically one grouping of these numbers. We are used to writing this out, and this form, these grouping of numbers, this is referred to as decimal. Well, computers, they use binary. You may have heard of binary. Binary is ones and zeros. So within this IPv4 structure, it uses binary as the primary code that computers read. Binary equals ones and zeros. So binary is going to look something a little bit like this. Your first octet for this number would be that is just this first octet. That's our second octet. This would be our third octet. And then our fourth octet. Now each octet, as you can see, has 8 digits in it. So there's 8 numbers in here. They're going to be ones or zeros. Those are your bits. So you have 8 bits here, you have 8 bits here, you have 8 bits here, and you have 8 bits here. And that's how you get to your 32 bits. So that would be the 32-bit structure on IPv4. Now, as you can tell, that's extremely tedious. This is extremely hard. This is how computers read data. They read all of their data as the bit is either on or the bit is off. And that's what the 1 and the 0 indicate. The 1 indicates that the bit is on, the 0 indicates that the bit is off. In a 32-bit structure like IPv4, computers use binary. They use ones and zeros. If we had to do this, it would be extremely hard, tedious, and you could imagine what would happen if we get it wrong. So we had to create something that resolves this binary number into a decimal format that we can read and we can actually work with. And that's what we were looking at up here. So if we took this and we use the binary uses a base 2 system. Base 2 system. So if we follow and we know what a base 2 system is, it starts off with a 1, then it goes to 2, then it goes to 4, then it goes to 8, then it goes to 16, then it goes to 32, then it goes to 64, and then it goes to 128. Maybe a little bit hard for you guys to read. But this is the basic structure of an 8-bit system. And so what we do then is we translate it. I'll write that a little bit bigger for you guys. So the 8 bits using the base 2 system look like this. Now, as you can tell, those are your numbers. So this is your base 2 system. This is how we resolve binary into a decimal format. So we look at each one of these octets, and we look at each one of these groups of 8 bits, and we establish if the bits are on or if the bits are off. If the bits are on, we count using our base 2 numbering system in order for us to resolve into the decimal format. So because this bit, and these 2 bits are on, in this octet, we would add 128, we would skip the 64 because it's off, we would add the 32, and then we would add the 16, and we would add the 8. And that's going to give us 172. That's how we resolve this first octet into decimal format. Then we move on to the next, and we would use the same base numbering system in this octet. So just looking at it, which bits are on? We know the 128 bit is off, the 64 bit is off, the 32 bit is off, we know the 16 bit is on, and that's our number. All the rest of them are off. So we just take our 16 and pop it down there like so. Now over in this octet, all of them except for the last one are on. And so if we added up 128, 64, 32, 28, 8, 4, and 2, we're going to get 254. And then our very last octet, all of them are off except for the first bit, or the last bit, depending on how you look at it, which is just going to give us the 1. So this is how we resolve binary into the decimal format in order for us to actually work with it. And we have to keep this consistent, and this is like what we talked about with the TCP/IP protocols. Everything has to be consistent across the board. Programmers and network administrators, they have already established the coding, the programming. We as network administrators and configurers, we have to use what they're providing us as far as formulas go. All these machines that are out there today use IPV4 or they use IPV6 in order for you to configure an IP address on them. When you're configuring an IPv6 or 4 address on them, you have to use the appropriate format. This is the decimal format. This is what we would use. We would use a group of 4 numbers separated by a dot. The computer is going to resolve them to a binary format, and that's how they're actually going to read them. I just wanted to introduce to you a little bit about the concept on the 32-bit structure, the 4 different octets, how binary worked, how the base 2 system worked, and then how it all resolves it to the decimal format, because this is our IP address. This is what we use right here, the 172.16.254.1. We would either assign that to a device within the network or configure it for something in this network. That's what it's going to use.
Okay, so let's talk a little bit about private addresses and public IP addresses. So we've talked a little bit about the IPv4 address range. Well, if we want to think about it, the IPv4, again, it's the 4 octets. It's a 32-bit structure. So the biggest possible range for an IPv4 address is 0.0.0.0 through 255.255.255.255. That is the most possible range that we can have within our IPv4 structure. Well, some of these within this range are blocked off for private IP address scheming. All the rest of them are going to be public. So we'll talk a little bit about some of these. So what are private IP addresses? Well, these are the private IP address ranges. So we have the 10.0.0.0 through 10.255. That's all private address. That entire block is all private addressing. The 172.16 through 172.31.255, again, that's all private. Same goes for the next address block of 192.168.0.0 through 192.168.255.255. All 3 of these blocks of addressing are used for private IP address scheming. What that means is when you're on the inside of your network, these are what companies use, these are what people at homes use. These are what small businesses use on the inside of their network, on their LANs. We'll get to that in the next segment here. You also have an auto configuration range and a loopback range that are also reserved. We'll talk about these a lot later in our courses when we're configuring devices, because we're going to be using some of these ranges on certain devices, which are going to help us for troubleshooting and help us to make sure we have the appropriate configurations on some of these. So the use of private addresses. We use those private address blocks on our own local area networks, our LANs. The LAN that's really on the inside, your entire network that's connected on the inside of your structure, that is not directly connected out to your gateway. If you think about it, your entire computer network is going to be like a little spider web, and you're going to have one gateway that's going to take you to the outside world. That's usually your modem or your router. If you didn't have a modem or a router, you can actually still have your network set up. You're just not going to be able to communicate with anyone that's outside of your small private network, your local network. So we use these private addresses to assign those to devices that are inside our own private network, inside our LAN. And we use the auto configure and loop back for actual configurations on other devices we'll talk about later. All those other addresses that are not within the private range, and they're not loop back and not within the auto config, those are considered public IP addresses. What are public IP addresses? Well, like I said, any 4-digit IP that's not within the private range, the auto configure, the loop back. They're used for websites, internet service providers, web servers, email servers. So when you go and you get an internet connection and you pay Comcast, Cox, CenturyLink, someone like that for an internet service, they're going to come and they're going to put a modem in your home, whether it's DSL or cable or whatnot. Now, that is going to have an IP address assigned to it. That's also called your gateway, because that is how you connect to the world. It's how you get out there. It's how you connect. You can send email. You can get on the internet. You can download things. All that's done now because you have a router. You have a modem. So those modems, they have an IP address assigned to them. Because it's from your internet service provider, it will be a public IP address, because that's how you get out to the world. That's how the world gets into you. It's going to hit your gateway, your router, your modem, and then it's going to be broken up into your network on the inside. And that's what we mean when we're talking about our inside network. So one reason why we haven't run out of address space right now is because of NAT. NAT is Network Address Translation. What I was just talking about with your internet service provider having an IP address and it hits your router and then it comes into your network, and we use that private address schemes within those blocks for our private addresses, that is what is all made possible by NAT. If we didn't have NAT, we would have ran out of address space a long time ago and we would have been in deep trouble. Well, IPv6 will essentially solve that, but IPv6 is not 100% implemented across the board. IPv4 is still pretty prevalent for what we're doing in today's world. So NAT has really saved our butts. NAT allows us to use the private address scheme inside of our network, and then it translates it to our public as we hit our router, hit our gateways, and we go to the outside world. And that's allowed us to utilize more address space. So not every device we use has a public address. Most of which are all going to have private addresses. Other things we use that go on to the outside of the gateway, then we get the public address space. So it allows us to use all of our private IP addressing inside our LANs, inside our network. NAT's applied at our routers and the gateways to the outside world. Well, what is DNS? So we talked about NAT, now we're going to talk a little bit about DNS. DNS is Domain Name Services. So what it does is it actually resolves websites into IP addresses. Now I'm just introducing some of these concepts because they're going to become really relevant when we really start getting up to our elbows in a lot more material down the road. I introduced to you guys a very basic concept on the whiteboard, which was binary and decimal. Computers and devices, they use binary. That's how they read it, the ones and the zeros. It's very hard for us, so we configured IPv4 to converting it into a decimal format in order for us to read and us to work with? Well, just like the same concept, web servers, websites, routers that are out there in the world that basically allow us to connect to different information, they don't know what websites are. So when you go into your web browser and you type in www.nfl.com and you hit enter, your computer, the web server, has no clue what NFL.com is. It doesn't actually speak that language. They use ones, zeros, which get translated into decimal form for them and essentially binary down the road. So that's what DNS does. DNS is a domain name service. It resolves that for us. So the minute you type in www.nfl.com, you hit the enter button, your computer goes, what the heck is this guy telling me to do? Well, DNS says, hey, he wants you to go here. He wants you to go to this IP address, this public IP address of this web server, and it's 184.180.124.97. And your computer goes, oh, now I know what he wants to do, and it brings up that web page. So if we didn't have DNS, again, we would have to be typing in all these IP addresses every time we wanted to go anywhere. Could you imagine what the world would be like if we didn't have DNS? It would be horrible. You wouldn't have any of the clever website names out there. So that's what DNS does for us. Again, we're just introducing some of these concepts because we're really going to be getting into a lot of that stuff later. So in the conclusion, we talked about what IP addresses are. We talked about the two forms, the IPv4, the IPv6. We talked about the IPv4, the 32-bit structure in binary. And then we talked about the public and the private IP addresses. We also talked about the NAT and the DNS. Now again, I'm not expecting anybody to watch this video and understand all of these concepts. As I mentioned in the beginning, this is simply a movie to introduce you to some of these concepts because you have to understand some of these concepts. The next stuff we really get into, we're going to be jumping into it up to our elbows. So if you don't know what any of these things were introduced before, you might have felt a little lost. I really appreciate you watching the video, guys. Please share it. Please like it. Ask me any questions that you have, and we'll get rolling into the next stuff. Thanks, guys.